Hello everyone, welcome back to the channel. Now we are going to start with a new data structure, that is AVL tree. Okay, so now first let's understand what is AVL tree and why we need to learn it. Okay, so AVL tree, as you can see, invented by Gregory Adelson, Welsky and Evgeny Landis. Okay, to be honest, till date for me it's really hard to remember these names and pronounce as well. So let's understand what is AVL trees. Okay, so AVL tree comes in the category of self-balancing binary search tree. Okay, so there are two types of trees, balanced binary search trees and unbalanced binary search trees. Okay, so what do you call unbalanced binary search tree? Let's say you have a sorted list. Okay, you want to convert that sorted list into a tree. Okay, so first you added one element, then you keep on adding one element after it, right? So again you are actually creating a list even if you want to create a tree. Okay, so those type of trees are called right skew tree or left skew tree. So those are unbalanced trees. You don't want those unbalanced trees. So there are different algorithms to make them balanced. So that's where this category comes of self-balanced binary search trees. While inserting itself, that particular element figures out if your tree is in a balanced state or not. If it is not in a balanced state, it understand that there needs to be a balance situation. Okay, how it balance? So different trees, different trees do this self balancing in a different ways. If you talk about AVL trees, the AVL tree does it in terms of rotations. So just now we talked about, right? There are other self-balancing trees as well. There is red-black trees, also called as RB trees, B trees, splay tree, 2, 3 trees. They are really highly advanced trees. Okay, they are not even asked in interviews, to be honest. And just now we understood what is balanced and unbalanced trees. Okay, so there's something called as balance factor. We calculate it, to know if the tree is balanced or not. Based on that, we detect what type of rotation we have to do, and then we perform that rotation. I'll be talking about those rotations in detail, and also you will be implementing every single thing that I'm telling you, okay, in code. So yeah, so if your tree is unbalanced, right, even in tree your operations can have a time complexity of O of n, that is linear time complexity, which is not a good time complexity. Okay, trees are popular for their logarithmic time complexity, that is log n. That's why we that's why these self-balancing trees are very important. Just to summarize what we are going to do in AVL trees, I have summarized it in single line. It detects if the tree is balanced or not based on the balance factor after each element insertion, then perform rotations accordingly to balance binary search tree. Now this is all that we are going to do in this AVL trees. And trust me, this itself needs a lot of logic and implementation, a lot of thought process goes into it. Okay, so what are those rotations? How do you perform it? We'll learn about them in detail. For now, just understand there are four types of rotations that we do. There is LL rotation, that is left rotation. There is RR rotation, that is right rotation. There is LR rotation, that is left right rotation. There is RL rotation, that is right left rotation. Okay, so you will understand in which case which rotation is followed. Okay, and after it is followed, how your tree is actually getting back to your balanced state. So we'll be understanding all about this, and we'll start with some normal operation like insertion and all. Okay, and slowly we'll learn about the rotations as well. We'll implement as well, obviously. So I hope you got a good overview on what is AVL tree. AVL tree is part of a self-balancing trees, and we'll be implementing in the next videos. That's all I wanted to explain as part of this video. See you in the next one. May the source be with you.